Let's continue our work here. Remember, again, as we're going through the notes, we also have the textbook that has a lot more information for you, especially this video at the beginning around thinking about um, the mathematical brilliance of young people. There's a short little video there from one of my mentors, Dr. Megan Frankie from UCLA, talking about the brilliance of math students and then teachers talking about that. So don't be hesitant to go back and look at that a little bit. Let's continue now as we were talking about these sets and how they could occur in our world, right? And now we're just talking about the formal notation. So another formal idea is called a subset. So when we have a set of things, we can have a smaller piece of that subset, and you can kind of see it in this picture here. We have like a set of objects, and we do it through a picture called a Venn diagram. So you will see like A is part of B. So we would say A is a subset of B. Now, to be formal with our language, we can call something, and we have this notation here. Notice we use this kind of C with a line underneath. A is a subset of B, which means A is a part of B, or actually could be equivalent to B, sorry, equal to B. And that's kind of that little line, a half equal sign, that it could be equal. I could use this also. So if A and B were equal, I could also say this because it includes, is it a subset or equal to? And so we also have this formal language of a proper subset, which just means that A is actually included inside of B, but does not contain anything from B. So again, just formal language. So I don't want you to get too caught up. We'll talk more about that. Again, we're in the subtleties. We're talking about the language because we have these little technical things that students will ask about. And so you want to be aware that we have these technical things, right, that we want to pay attention to. And that's why we need to define things appropriately. Back to the definition of a subset. Now, moving forward, like I said, this image here of sets can be done with Venn diagrams, and that's what we introduce here. We'll talk more about Venn diagrams as we move forward. So let's take a look at examples. Since I'm done explaining, we have 3 examples back to back here. So again, if we're talking about in verbal description, let A be the set of all counting numbers less than 8. That's a verbal description. We could also write it this way here, which is the set notation, or we can have, we could look here as going back to the names over here, where we said we had the 3 ways to describe it. We had their set builder notation, and then we had the list, that's what I was looking at now. The list can list it this way with the braces, or a more formal language, right, using this form. You see this a lot in algebra classes or advanced math classes, this very formal language. Mathematicians like that because it's precise. We just got to understand what it means. In 2.2, we have 2 different sets, and so we ask you a question: is A a subset of B, right? Is it true that A is a proper subset of B? And so in this case, A, B, C, D, E, and then you have this bigger one here. So A is a subset of B, and it's also a proper subset, meaning that all of its elements are inside of it. They don't. Um, so these are both true statements. Again, you could be confused. The notation is it a subset of B? This is it a proper subset. So the notation still, so it could be equal to, and this would still be true, but it's not. It's still a subset. So the equal doesn't come into play there. So just keep that in mind. Again, that's subtle. You may have to pause and think about that, or ask further, or ask our Google Notebook, or ask ChatGPT or an AI to help it, or a friend, right, to help with that, or me in class. 2.1.3, is A proper subset of A? That's false. A is a subset of A, which is true. A subset or equal to A is true, but A is not a proper subset because they have the same elements, no matter what A is for any set A. Is the empty set a subset of A, or a proper subset? It's true, and this is by definition. This can confuse people also, but by definition, we have that the empty set is a subset of all sets. A set can have no elements. Remember that. We'll stop there, and then we'll continue on.